Hello friends, welcome to the sessions of lectures of Mathematics-02. Up to last session, we have learned the method to solve first order first degree differential equation. In today's session, we are starting with a first order higher degree differential equation. Now, how to solve the first order higher degree differential equation? So first of all, if you have an equation of the form f of x comma y comma dy by dx is equal to 0. That means dy by dx is our p. Okay. Then this equation, if you have a single power of dy by dx, then it is a simple first order first degree differential equation. But if you have more than one power, then that is called the higher order higher degree differential equation. Correct? So in that case, it is known as a first order higher degree differential equation. Now, there are three cases. It can be solved by three methods. First one is equation solvable for p. Second one is equation solvable for y. And the third one is equation solvable for x. Now, first of all, in today's session, we are going to start with a equation solvable for p. Now, first of all, suppose if you have a polynomial p raised to n plus capital P1 into small p raised to n minus 1 plus capital P2 into small p raised to n minus 2 and so on, capital P1 into p plus capital P0 is equal to 0. Now, this is the polynomial where capital P1, capital P2 up to capital Pn are P1, P2 up to P of n minus 1 and P of n, okay, are functions of x and y, okay. So, if you have the functions of x and y, then this equation is said to be solvable for p if you can factorize this the left hand side in the form of f minus some function of xy into p minus some another function of xy and so on, p minus some function of xy is equal to 0. That means you have first degree factorization of polynomial of p in left hand side. Then what we are going to do, we are going to equate each term with equal to 0 and that will give you p is equal to f1 of xy, same manner p is equal to f2 of xy and continuing that manner p is equal to fn of xy. Correct? Now solve all of them and find out the solution. Capital F of x, y, c is equal to 0. Same manner capital F2 of x, y, c is equal to 0 and so on. Capital Fn of x, y, c is equal to 0. Now see, here we have taken a single c because see, you have first order differential equation, so all the constants remain same. And using this all solution, the general solution is given by simply f of f1 of x, y, c into f2 of x, y, c into up to fn of x, y, c is equal to 0. Now, it may happen that using these equations, if you are not able to find out p, then in that case, it may be solvable for y or it may be solvable for x. That we are going to discuss in next lecture. So, first, we are starting with a solvable for p. Now, suppose here you have given p square minus yp is equal to xp minus y. So, if you are writing this in the form of, then I am going to write this in the form of p p square minus yp minus x into p minus y is equal to 0. So here p common out and you will have p minus y minus x into p minus y is equal to 0, and that will give you factor p minus y into p minus x is equal to 0. So you will have p is equal to y or p is equal to x. Now p is nothing but it is your dy by dx. So this is going to be a dy by dx is equal to y or dy by dx is equal to x. So here you have dy upon y is equal to dx, and here you have dy is equal to x dx. So integrating both sides, that will give you log y is equal to x plus c. Same manner here you have y is equal to x square by 2 plus c. Now, if you are going to solve this, that means we are writing this in the form of log of log of y minus x minus c is equal to 0, and you have y minus x square by 2 minus c is equal to 0. So this is your equation number 2, this is your equation number 3, and therefore the general solution is given by multiplication of these two. That means log y minus x minus c into y minus x square by 2 minus c is equal to 0. Correct? See, log y minus x minus c and y minus x square by 2 minus c. So this is the answer or solution of your differential equation which has a higher degree. Correct? Okay, same manner we are going to take another example. Here what you have p cube minus 3p square minus plus 3x p square minus y cube p square minus 3x y cube p. So what I am going to do, I am going to pair them. Here p square common out and you will have p plus 3x. Here minus y cube into p common out. So you will have p plus 3x, and that will give you p plus 3x into p square minus y cube p is equal to 0. So p plus 3x, here p common out and you will have p minus y cube is equal to 0. So we have p plus 3x is equal to 0 or p is equal to 0 or p minus y cube is equal to 0. So here you have dy by dx is equal to minus 3x or dy by dx is equal to 0 or dy by dx is equal to y cube. Correct? So you will have dy is equal to dy is equal to minus 3x dx or dy is equal to 0 or dy upon y cube is equal to dx. Correct? Okay. So now integrating both sides, that will give y is equal to minus 3x square by 2 plus c. Same manner here you have y is equal to c. Same manner here you have, this is y raised to minus 3, that means y raised to minus 2 upon minus 2 is equal to x plus c. So this can be written as y plus 3x square by 2 minus c is equal to 0. This can be written as y minus c is equal to 0. And we are writing this term opposite sides for x plus 1 upon 2y square plus c is equal to 0. And therefore, the general solution is given by y plus 3x square by 2 minus c is equal to 0. Sorry, you have to multiply them. So first solution into second one, that is y minus c, into third one, x plus 1 upon 2 y square plus c is equal to 0. So this is the method to solve the equation solvable for p. Okay. We are going to take one more example and very simple one. Suppose you have given solve p square minus 9p plus 18 is equal to 0. See here there is no x or y. But you can factorize this. If you are considering this, then this can be written as p square minus 6p minus 3p plus 18 is equal to 0. Correct? So, this can be written in a form of p into p minus 6 minus 3 into p minus 6 is equal to 0. Correct? So, the factors are p minus 6, p minus 3 is equal to 0. And that implies you have p is equal to 6 or p is equal to 3. Correct? And that implies dy by dx is equal to 6 or dy by dx is equal to 3. And that will give you dy is equal to 6 dx or dy is equal to 3 dx. And if you are going to integrate, then you will have y is equal to 6x plus c and y is equal to 3x plus c. So you will have y minus 6x minus c is equal to 0 and y minus 3x minus c is equal to 0. And therefore, the general solution is y minus 6x minus c into y minus 3x minus c is equal to 0. Okay. So this is the method to solve the equation solvable for p. But here it is necessary that the polynomial must be factorizable in a form of p. Otherwise, you cannot apply this method. Okay. Now, these are the topics which we have covered in today's session. If you have any doubt or any query regarding these topics, then please feel free to contact me. Thank you so much.